Hello everyone, this is Yogesh. Welcome to my channel No More. Today we'll be discussing about computer processor. Let's get started. The CPU or the central processing unit is the primary component of a computer that processes the instructions. It runs the operating system and applications, constantly receiving input from the user or the active software components. That means software programs. It processes the data and produces the output, which may be stored by an application or displayed on a screen. So let's talk about the components of CPU. The first component is the register. A register is a temporary storage area built into CPU. Some registers are usually internally used and which cannot be accessed outside of the processor, while some others are user accessible. So most modern CPU architectures include both type of registers. The registers are of different type like instruction register, memory buffer register, memory data register, and memory address register. Apart from that, also many of the CPUs nowadays have a general purpose registers, that is GPR, which may contain both data and memory addresses. Coming to the next component, that is the ALU. It stands for arithmetic logic unit. An ALU is an integrated circuit within a CPU that performs the arithmetic and logical operations. Arithmetic operation includes the addition of and subtraction of integers, while logical operations include Boolean comparisons such as AND or NOT operations. ALUs are designed to perform integer calculations. Therefore, besides adding and subtracting, they also often handle the multiplication of two integers, since the result is also an integer. Interesting fact is that ALUs typically do not perform division operations, since the result may be a fraction or a floating point number. So, division operations are usually handled by the floating point unit or FPU, which is also performs other non-integer calculations. So as I told, the FPU stands for floating point unit, and an FPU is a processor or part of processor that performs floating point calculations. While early days the FPUs were standalone processors, and most are now integrated inside a computer CPU. So even without a floating point unit, a CPU can handle both integer and floating point or non-integer calculations, but the integer operations use significantly different logic than floating point operations, which makes it inefficient to use the same processor to handle both type of operations, that is integer and non-integer. An FPU provides a faster way to handle calculations within non-integer numbers. So any arithmetic operation, if it comes to CPU, such as addition, subtraction, multiplication or division, it can be performed by either integer processing unit or the floating point processing unit. So when a CPU receives an instruction, it automatically sends it to the corresponding processor. So suppose the CPU gets an instruction for addition of two integers or subtraction of two integers, then it will be sent to the ALU, and if it receives any operation which is related to any floating point number, then it will be sent to the FPU. Coming to the next component, that is the cache. The cache is usually used by the CPU for faster processing. It stores recently used information so that it can be quickly accessed at a later time. So computers incorporate several different types of caching in order to run more efficiently, so thereby they improve the performance. So here we are talking about the processor cache. So processor caches are even smaller than the disk caches. This is because a processor cache contains tiny blocks of data such as frequently used instructions that can be accessed quickly by an CPU. So modern processors have different types of cache, that is L1 cache, L2 cache and L3 cache. So let's discuss about CPU core. So what is a CPU core? So for understanding this, let's discuss about kinds of processors. So we actually have two kinds of processor, that is a single core processor or a multi-core processor. Originally CPUs had a single core. That meant the physical CPU had a single central processing unit on it. To increase the performance, manufacturers started adding additional cores or additional central processing units to the central processing unit chip or the CPU chip. A dual core CPU has two central processing units, so it appears to the operating system as two CPUs. So in parallel execution, the tasks to be performed by a process are broken down into subparts, and multiple CPUs or multiple cores process the subtask at the same time. So it makes the particular operation easier and efficient. So let's talk about the available CPU cores. So in market we have a dual core CPUs, that means it has two cores or two central processing units. In quad core we have 4, in hexacore we have 6, in octa-core we have 8, in deca-core we have 10 central processing units. So let's talk about threads. So a thread is a unit of execution of a concurrent programming, means it's a part of multi-threading. So multi-threading is a technique which allows a CPU to execute many tasks of one process at the same time. These threads can execute individually while sharing their resources. So in early 2002, Intel brought a new concept called hyperthreading, and which is the actual part of the parallel computation which brought by Intel to the consumer PCs. So a single physical CPU core with hyperthreading will appear as two logical CPUs to an operating system. So let's see. So here in this diagram we have 4 CPUs, that means 4 central processing units in a single chip. So this is the design of a quad core processor. So in one core itself we can have 2 threads. So these 2 threads will be visible as 2 different central processing units or CPUs to the operating system while processing the request. So in a quad core processor we will have 8 threads. So physically we have 4 cores, but logically we have 8 threads. That means physically this CPU chip is having 4 cores, and logically this CPU is having 8 CPUs. That means this CPU chip or this processor is having 8 CPUs or central processing units. So let's have an example. So in this screenshot you can see this is a i3 6th generation CPU, and you can see the highlighted portion which says it has one socket, 2 core, and logical processors are 4. That means it has one physical chip or processor chip which is having 2 cores, that means it is a dual core CPU, and the logical processors are 4, that means it has 4 threads. So let's discuss about the manufacturers of CPU chips. So at this moment in market we have many CPU companies or manufacturers available, but out of them 2 are leading in the race. They are Intel and AMD. The AMD stands for Advanced Micro Devices. So they have different series names associated with all the products. So, for Intel we have the Core i3, Core i5, i7, i9, they have a family, and these family have the dual core, quad core, octa core, hexa core, deca core processors and so on. Also these family or the I series family have processors which have 18 core. Similarly, in AMD Ryzen we have the processors having dual core, quad core, hexa core, octa core and so on. It also has the processors having 64 core which are meant for desktop, mobile and embedded platform processors. Let us talk about the CPU naming scheme. So, how to identify a particular CPU or a processor generation and what is the features of that particular processor from the name itself. The leftmost one it shows the Intel processor naming convention and the rightmost one shows the AMD processor naming convention, and both looks appears to be same. Let us talk about the Intel naming convention. The Intel Core is nothing but this is the brand name, and i9 is the series name, and there is a 4-digit sequence, that is 9900. So, the first 9 is the generation number, that means the first 9 which is in bold, it is the generation number, and the next 3 digits, that is 900, is known as the SKU, that is stock keeping unit, and it is a product part number. It also follows with a character that is known as the product line suffix. Here in this case this is K. So, this product line suffix denotes the processing power and some of the features, like here in the Intel processor the K is meant for unlocked version, that means this processor can be overclocked. Then we have the product line suffix like F, it denotes that it requires graphics. For T it is a power optimized, S it is a special edition. So, these are some of the product line suffix, and we also have the suffix like H and HK. These two are used for the mobile processor, that means the notebook or laptop processors. Similarly, in AMD the AMD stands for the brand name, FX stands for the series name. Then here also we have the 4-digit sequence. The first digit of the sequence, there is 8 which is in bold, is known as the generation number. Then it follows 3 numbers, that is 370, this is known as the SKU or the stock keeping unit, that is product part number. It also follows one character, that is E in this case, this is known as the product line suffix, similar to Intel processors. So, we have product line suffix in AMD like X, T which is used for the desktop, and we have H, M, U which is used for the mobile processor or the laptops. In AMD we do have another series that is called APU series, and the APU stands for accelerated processing units, and in these processors there is a built-in graphics involved inside the CPUs. Coming to the next, let us compare between couple of Intel and AMD processors, so that we will be able to know that what are the differences between them. So, you can see the last two columns, the second last column is the clock rate. So, what is the clock rate? The clock rate is typically refers to the frequency at which the clock generator of a processor can generate pulses which are used to synchronize the operations of its components, and it is used as an indicator of the processor speed. So, this is measured in clock cycles per second or its equivalent. So, here we are measuring in unit of hertz, and nowadays all the processors are coming in the clock rate of gigahertz. So, the last column it has a term called TDP. The TDP stands for thermal design power, sometimes called as thermal design point. This is the maximum amount of heat generated by a computer chip or a component that is available inside the processor, and this TDP is also taken into consideration for the cooling of the system. So, here you can see the top 4 rows represents, which are in blue color, represents the desktop processors, and the next segment of processors that is in red in color, these are known as the laptop or your mobile processors. So, for desktop processor you can see the Intel processors are having bit less TDP. That means these processors won't generate much heat, but if you can see the Ryzen processors of 7 series processors are having more TDP. That means they will generate more heat in watt. So, this TDP is measured in watt. So, but one more thing is that in the AMD processors you can see the number of core and threads are high. That means the performance will be good. So, let us come to the second section, that is the mobile processors. Here you can see the i7 8665U and the Ryzen 7 3780U. These two are having the same TDP, and these two are the same performance wise, these two are will be giving the same speed, because you can see these two are having the same number of cores, that is 4, and the same number of threads, that is 8. But here you can see the clock rate for the maximum clock rate for the Intel processor is bit high, that is 4.8, but in case of AMD it is in 4.0. So, here one more thing I just wanted to tell, that this maximum clock rate or the topmost means clock rate is denoted differently in different vendors. Like in Intel it calls as turbo boost, and in AMD they call it as a turbo core. Also you can see the last row, there is one more processor listed, that is Ryzen Threadripper, that is 3990X. So, you can see here the number of cores are 64 and the threads are 128, and it generates heat up to 280 watt. So, you can imagine how much amount of heat it will generate, but this is the one of the most demanded processor at this moment, and this is preferably used by the gamers, high end gamers, and those persons who are dealing with high end graphics or video editing, graphics design, etc. So, in previous slides we have seen that the Ryzen have a different series like Ryzen 3, 5, 7, 9. So, actually they denote the level of processing they offer. The Ryzen 3, these are the entry level, Ryzen 5 is mainstream, Ryzen 7 is the performance driven processors. Similarly, the Ryzen Threadripper is the high end desktop processors, because these are generally recommended for those people who are the heavy gamers and high end graphics designers or high end graphics editing or so. So, that is it for this video. So, I hope this video was useful for everyone, and please do subscribe my channel and hit the bell icon for the upcoming videos. Till then, take care. Bye bye.